Here, use tangent substitution to show that the integral going from 0 to 1 of the square root of 1 plus x squared dx equal to the integral going from 0 to pi over 4 of 1 over cosine cubed of theta d theta. Here, we're going to use tangent substitution, so we are going to refer to number 2 in here. Note, tangent substitution can be used when the integrand given in two forms, this form or the square root of that. Here, we are giving the square root. First, to make the substitution, we have to determine what is a. Note in here that a is equal to 1 in here. So a is equal to 1. Therefore, to make the substitution, x is going to be equal to a tan of theta. And that's going to be equal to 1 tan of theta. Now let's take the derivative of that. So dx going to be equal to, and then the derivative of tan, going to be 1 over cosine square of theta d theta. Now let's take the integrand and try to simplify it. So the integrand is square root of 1 plus x squared. That's going to be equal to square root of 1 plus, and then x is just tan of theta. So we're going to have tan square of theta. Now I'm going to use tan equal to sine over cosine. So this is going to be equal to 1 plus, and then tan square of theta going to be equal to sine of theta over cosine of theta, both squared. So that's going to be equal to square root of 1 plus sine square of theta over cosine square of theta. Now we want to make this into one fraction, so I'm going to multiply this by cosine square of theta, its dominator and its numerator. So that's going to be equal to square root, and then 1 multiplied by cosine square of theta. That's going to be cosine square of theta, and we're also multiplying the dominator, so it's going to be the same. Cosine square of theta, and then plus sine square of theta over cosine square of theta. This is going to be equal to 1 over, and then we combine that into one fraction. So the dominator is going to be cosine square of theta, and then we have cosine square of theta, and then plus sine square of theta. Now, I'm going to use this identity here, which is cosine square plus sine square equal to 1. So the numerator here is going to be equal to 1. Now I'm going to take the square root of the numerator and the square root of the dominator. Square root of 1 is just 1, and then square root of cosine square of theta is just cosine of theta. Now notice that the integrand in here is going to be equal to 1 over cosine of theta. Note in here we also need to change the limit of integration here using the tangent substitution. So we're going to use x equal to tan of theta. First we need to solve for theta. So theta going to be equal to the arc tan of x. We have two limits, so we have x equal to 1 and then x equal to 0. So theta going to be arc tan of 0, which equal to 0. And then for x equal to 1, we have theta equal to arc tan of 1, which equal to pi over 4. We can find these using the unit circle, or you can plug that into your calculator. Now let's take this integral and rewrite it using the tangent substitution. So we have the integral going from 0 to 1 of the square root of 1 plus x squared dx equal to the integral with the new limits. The new limit are 0 and pi over 4. And then the integrand is going to be equal to 1 over cosine of theta. And also dx here going to be equal to 1 over cosine square of theta d theta. That's going to be equal to the integral going from 0 to pi over 4. And then we multiply these fractions together. So we're going to have 1 over and then cosine cube of theta. Notice that when the base is the same, the power is added. And this is what I did for the numerator. I added the power, so we have 1 and 2. That equal to 3 d theta. And that should be our solution. Now notice that this is exactly the same term in here.